In section 26, we will look at exponential equations. The use of the calculator is required for this section. So first we will start by setting up our calculator with tables. So we'll be typing in the following into our calculator, and here are the steps for that. Our first step is to go to y equals, and we want to type in the three different equations. For the first one, for y sub 1, we're typing in 2 to the x. So you're noticing I'm using the caret key, and then I'm using up here x as my variable. For the next one, it's 2 to the x. We want to make sure we arrow over and put -1. And then for y sub 3, we're making this 2. I use the caret key to type in an x, and then it's going to be -1, and that needs to stay in the exponent. If you're using an older calculator, you would need to put that in parentheses for x minus 1 if it doesn't automatically put it in the exponent. Now from here, we're going to set up the table. So I hit second and then window, and I want to make sure the table starts at 0 and the change of table is 1. Then if I hit second graph, that's going to bring me to a chart that looks like that. For number 1, we're looking at which column or equation we will use to solve this equation. Well, when we look at the left side here, we have 2 to the x minus 1. And the one that's equivalent to that would be y sub 2. So we'll be looking at y sub 2, or we can think of that as the second column. Then we want to solve for x. So what we'll do is scan y sub 2 and we find 7. Wherever we find 7, the associated x value for that is going to be our answer. And in this case, that's going to be 3. It's always a good idea to plug these back in to check them then. If I plug in a 3 here, I've got 2 to the third, that's 8. 8 minus 1 is 7, therefore that is the correct answer. For number 2, same thing. We want to decide which of these we're going to use. And 2 to the x minus 1 is going to be column 3 or y sub 3. Now I'll scan that column and I'll find 8. Wherever I find 8, I look for the associated x value. In this case, that's going to be 4. So once again, if I plug this back in, I've got 2 to the 4 minus 1. That's really going to be 2 to the third, which is 8, so I can be confident about that answer. For number 3, I have 2 to the x is equal to 1. This one's going to use y sub 1 or column 1. And again, I'll scan that table. I find the value of 1 there, and that's associated where x is equal to 0. Once again, if I plug that in, anything to the 0 power, including this 2, would give me 1, so this is correct. For number 4, 2 to the x minus 1. Now I'm looking at y sub 2, and I'm looking again in column 2, and I'm looking for 15. And this time this is going to be y sub 2. I'm scanning that column looking for 15, and that is going to associate with the x value of 4. Once again, I'll want to plug that in. 2 to the fourth is 16. 16 minus 1 is going to give me 15, so we know that that's correct. For number 5 then, 2 to the x is going to be associated with y sub 1 or the first column. So from here, I'll scan that first column. I find 16. Once I find 16, I see that it is associated with an x value of 4. Once again, I can plug that back in and check it. 2 to the fourth does give me 16. For number 6, I will do the same thing. I look at 2 to the x minus 1. That's associated with y sub 3 or column 3. I scan that. I find the 4. It's associated with an x value of 3, so that will be our answer on number 6. So this is the graph of y equals 2 to the x plus 1. So we'll notice that in every single one of these problems, we have 2 to the x plus 1. What they're equal to is what we're used to thinking about as our y value. It's our output value. We're going to be looking for x, so we're looking along this axis to see where these numbers line up. So first of all, with number 7, when I'm looking at 9, I find 9 again on this axis, and it is going to cross the graph right here, and we're looking for the x value that matches up with that point. So as I look for my x value here, it's going to line up right there, and that's going to be 3. If I calculate 2 to the third, I get 8. 8 plus 1 does give me 9, so I can be confident with 3. For my next one, looking at that same graph, I'm going to look for 2 this time. So I come up to 2, and it's actually right here. So that's the point that I'm looking at. When I look at its associated x value, it's right here at the origin, which means that's going to be 0. Again, when I check it, 2 to the 0 power is 1, and 1 plus 1 is 2. Therefore, that is the correct answer. For number 9, now I'm looking for 5. I look at 5, I find the point where it crosses, which is right here. That lines up with 2. So 2 must be my answer here. Again, I'll check that. 2 squared is 4. 4 plus 1 is 5, so I can be confident about that. And then finally for 10, if I'm looking at positive 3, that brings me to this point right here. That lines up with an x value of 1, and so I'm thinking that that's my answer. Next, I'll go ahead and do 2 to the first, which is 2. And then 2 plus 1 gives me 3, so it checks out. Here's another graph. This is the graph of 3 to the x minus 1. So once again, if I'm looking for 9, I go up to 9. I find that point. It crosses right here, and that is lining up with 3. Next, I'll check that. If I plug in a 3 here, I've got 3 to the 3 minus 1, which is 3 squared, and 3 squared is equal to 9, so we're good there. For number 12, this time I'm looking at positive 3. That lines up right here, which is at 2. From here, I'm going to plug that back in and check it. So this is 3 to the 2 minus 1. That means it's 3 to the first, which does equal 3. For 13, I'm looking at positive 1, which is going to end up right here. So from here, when I look at the associated x value, that is going to be at positive 1. Once again, if I check that, 3 to the 1 minus 1 is 3 to the 0. Anything to the 0 power is 1. So this one might be a little bit hard for us to determine based on this graph. What we're seeing here is an exponential equation. And what's happening is that it's never actually going to cross over our x-axis in this case. And it does sort of look like it ends up on top of the x-axis here, but this dotted line right here is an asymptote. And if there's an asymptote right there, it's approaching it here as we move towards negative infinity, but it's not actually touching or crossing over it. So that means that we don't have a solution to that. And another thing that you can think about here is if you tried to plug in various numbers for x here to see what's going to give you a 0, you're not going to be able to figure anything out. You know, even if we tried like maybe a 1, well, 1 minus 1 is 0. Well, 3 to the 0 power is not going to give me 0. It gives me 1. So anything that you try for that is not going to work. The next thing we'll look at is which graph are we going to use for each of these expressions. So you'll notice that our base and exponents are different for each of these. My first one for 15, I'm looking at 2 to the positive x, and that's going to match up with graph A. Then what I'll do is go ahead and go to 2 on the y-axis. I find where it's at on the graph, and I look at the x value it lines up with. It does appear to line up with 1, so that is going to be graph A, x would be equal to 1. Once again, I should check that value. 2 to the first is 2, so I can be confident about that answer. For 16, this is 2 to the negative x. That's going to match up with graph B. This time I go to 2. That takes me over here to this point. When I look at what that lines up with on the x-axis, it's going to line up with negative 1. So now if I check this one, I've got 2 to the negative first, which is 2 to the first. It does equal 2, so I can be confident with that answer. For 17, I've got 3 to the negative x. That is going to match up with graph D. For this one then, I'll go to 9. I look at where it intersects. That's going to be here. And then if I look for where it's going to match up with my x-axis, I'm getting negative 2. Once again, I want to check that. 3 to the negative second is 3 squared. 3 squared equals 9, so now we know that that's the correct answer. For 18, I've got 3 to the x. That's going to be graph C. Now I go up to 9. I look at what it's lining up with. It's going to line up with 2, so that should be my answer. Once again, 3 squared equals 9, so I know that that's correct. For number 19, 2 to the negative x, that's going to be this graph right here. I'm going to go to 1/2, and that's going to be a little bit hard to estimate here. So if I go up a little bit and then look over to see where it lines up with, it appears to be in this position right here where I have that dot, and that looks like it's lining up with 1. But if we're doubting that at all, we can figure out if it's correct right now. As I plug this 1 in for the x here, I've got 2 to the negative first. And we learned in a previous section that if you have negative exponents, they need to move. So if that 2 to the negative first is currently in the numerator, as it moves to the bottom, it loses the negative. So this would be 2 to the first in the bottom. So 1/2 is equivalent to 2 to the negative first. My last one on this page, number 20, 3 to the x is going to match up again with graph C. This time we're looking at where it's equal to 1, which looks to be about right here. And that is lining up with 0. Once again, we want to check that. 3 to the 0 does give us 1, so we know that that's the correct answer. Now we're looking at solving some of these equations that have the same base. So as long as they have the same base, what we'll do is set their exponents equal to each other. So in the case of 21, they have the same base, so I can go ahead and set 2x plus 3 equal to 4x. And then I solve from there. So you can see here I've subtracted 2x. That's going to give me 3 is equal to 2x. From there, if I want to get x by itself, I'll divide both sides by 2, giving me 3/2 for this one. Now we should always be checking our answers. So if I plug that 3/2 back in, 2 times 3/2, well, the 2's would cancel there, so I'd get 3. 3 plus 3 is 6, so I've got 7 to the 6 on this side. Over here, if I'm doing 4 times 3/2, the 2 in the denominator for the fraction is going to cancel with that 4, making that 4 a 2. So I'm left with 2 times 3, which is going to be 6, so that did check out. For 22, here, again, bases are the same, so set the exponents equal. And with that, I can go ahead and just distribute those in. So that's going to give me 3x plus 3 is equal to 7x minus 21. From here, I continue solving. So we can subtract over this 7x to get negative 4x, or maybe you would have subtracted over the 3x. And then here we subtracted 3 to get negative 24, divide both sides by negative 4, and we get x is equal to 6. It's possible that you had 24 is equal to positive 4x, and then you would still get 6 on this one. Now if I check that, 6 plus 1 is going to give me 7. 7 times 3 is 21. Over here, I've got 6 minus 3, which is 3, and 7 times 3 is also 21, so that checks out. And then for 23, again, I have the same base, so I'll go ahead and set those exponents equal. By distributing this 2 in, I get 2x plus 2 on the left is equal to x plus 9. I subtract an x over, I subtract a 2 over, and I get x is equal to 7. Once again, when I go to check this, plugging this in here, I've got 2 times 8, which is going to give me 16, and then over here I've got 7 plus 9, which is also going to give me 16. Now in these examples, they don't have the same base. So in order to solve them like we did in the previous setup, we're going to need to get them to have the same base. We're just going to work on the setup here. We're not going to actually solve these expressions. So when I'm looking at the bases right now being 4 and 2, I'm going to start by looking at this smaller number as being my base, and I want to see if that would possibly work for both. So in other words, I'm looking to see if this 4 can be written to have that base, and it can. 4 is the same thing as 2 squared. So since 4 can be written as 2 squared, I just want to remember that I still have this 2x plus 1 here. So I would accept this setup right here, or if you had already distributed the 2 in and got 4x plus 2 in the exponent, that would be fine as well. For number 25, again, I'm going to start with this 3 and think, can I make this have a base of 3? Well, 27 is the same thing as 3 to the third. So I can write 27 as 3 to the third and keep that 4x minus 7 there. And if I could either go with this, or I could then distribute this 3 in and get 12x minus 21. And certainly if we were solving it, we would want to do that. For 26, again, I start with this 25 and I think, can I write this one to have a base of 25? And in this case, no. So instead, I'm going to look at 25 again and I'm going to think, well, what could I use for that? Well, 2 doesn't work, 3 wouldn't work as a base, 4 wouldn't work, 5 does. So this is the same thing as 5 squared. So now I'm trying to decide if this can be written with a base of 5. And it can. That would be the same thing as 5 to the third. So on the left side, I'm going to get 5 to the 3x, and on the right side, I'm getting 5 to the second for 25, and then in parentheses 6x minus 18. From there, I would be able to distribute that 2 in again if we were going to go that route. For 27 through 32, we are going to actually solve these equations. So once again, we're going to look for getting the same base. And in 27, there's actually a couple different bases that you could use here. The way that I would probably suggest that you start this problem is to think about this 9 again. And I'm going to say, well, 81 could be written as 9 squared. So one method would be to leave this side alone and then to change the 81 into 9 squared, making its exponent 2 times the quantity 2x minus 5, which would then be 4x minus 10. You could use that setup to solve. The way the work is going to be shown here is by going with a base of 3. Again, it's not necessary to go with the base of 3 on this one. You could have gone with the base of 9, and I would say that that's almost the better option for this particular problem. So if I do choose to go with 3's here, 9 is the same thing as 3 squared. So I'll have 2 times the quantity 3x minus 1. Over here, 81 is the same thing as 3 to the 4th. So I'll have 4 being multiplied by 2x minus 5, and I'll distribute that in. So on the left side, I end up with 6x minus 2, and on the right side with 8x plus 20. I solve from there. Subtracting 8x over gave me negative 2x. Adding 2 over gave me negative 18. Dividing by negative 2 is going to give me 9. For 28, again, I'm going to look at the smaller of the two, and I'm thinking 2. Can I write 8 as 2 to some power? And I can. 8 is the same thing as 2 to the 3rd. So this is going to be 2 to the 3rd with 3x minus 1 in parentheses. Once again, I'll distribute that in. And I'm just looking at the exponent here. That's going to be 9x minus 3. Because again, once our bases match, we only care about the exponents. From here, this side I didn't have to change. It's just going to stay x plus 15. Then I'll subtract x on each side, giving me 8x on this side. Add 3, giving me 18 on this side. I divide both sides by 8 here. 18 divided by 8 is going to reduce to 9 over 4, and that will be the answer. Now for 29, when I'm looking at these two, again, I start with the 16 and I think, can I write 64 with a base of 16? Well, 16 squared is going to be a lot bigger than 64, so that is not going to work. So I'm going to go back to 16 and I'm going to think about some different numbers that might work. One thing that might be coming to your mind because you're thinking that it goes with both is 8. The problem is that 8 does not, it would work for a 64, but it would not work for a 16. 8 times 2 is 16, but it would have to be 8 to a power. So now I'm going to think about some other things that might work. Well, 4, for example, I could use 4 on this one. This would be the same thing as 4 to the 3rd, and this would be the same thing as 4 squared, and that would be an option. So I could take 3 and distribute it into x minus 1, and I could take 2 and distribute it into 2x minus 5 and solve. What I'm showing here is a base of 2. 2 to the 6th power is going to give me 64, and 2 to the 4th power is going to give me 16. Here I'm distributing in this 6, and here I'm distributing in this 4, giving me this right here. From there, if I subtract over 8x, I'm getting negative 2x. If I add over the 6, I'm going to get negative 14. Finally, if I divide both sides by negative 2, that's going to give me 7. Now for 30, when I'm looking to get the same base here. So when I'm looking at the next one, again, if I'm comparing 100 and 100,000, I want to go with the same base on each side. I might try 100. Well, if we type in 100 squared, it's going to give us 10,000. So that is not going to be big enough for 100,000. But if I went to raise that to the 3rd power, then it's going to be too big. So I cannot go with 100 as my base. Instead, I'll go with 10. 10 squared is equal to 100. I will have to distribute that 2 in. And then over here, 10 to the 5th is equivalent to 100,000. From there, I'll set the exponents equal. This becomes 4x plus 2 is equal to 5. We subtract 2, we get 4x is equal to 3. Divide by 4, and I'm going to get 3/4 for this one. For 31, again, if I look at 9, 9 is not going to work for both of these. Because if I tried to do 9 squared, that's 81, so it's too big. So I'm going to have to go with 3's on this one. 27 is the same thing as 3 to the 3rd. I'll be distributing that in. 9 is the same thing as 3 squared, and I'll be distributing that in. From there, I get 3x plus 15 is equal to 4x plus 6. If I subtracted the 4x over, I've got negative x. If I subtract 15 over, I'm getting negative 9. I don't want to know what negative x is, so we divide by negative 1, and we get x is equal to 9. Then finally for 32, 25 and 125. I can't use 25 as my base for both. 25 squared would be 625, so that would be too big. So instead, I want to think of something else that's going to work. 2 doesn't work, 3 doesn't work, 4 doesn't work, but 5 would work. So 25 is the same thing as 5 squared. That's going to make that side become 5 squared times 3 minus x. Over here, 125 is the same thing as 5 to the 3rd, and that's being multiplied by x plus 1. Distribute those in, we end up with 6 minus 2x on the left side, 3x plus 3 on the right side, and we solve from there. So from there, if I subtracted 3x over, I get negative 5x here. If I subtract that 6 over here, I should have ended up getting a negative 3 right here. And then from there, if I divide both sides by a negative 5 at that point, it actually should have come out to be positive 3/5 on this problem. So this, again, is a typo. We do want to go with positive 3/5 as our answer here. So finally, I'd like you to go ahead and work on the exit slip for today's lesson. You'll also complete practice set 26 for homework tonight.